So we're just going to look now at using PyTorch with UV. And one of the things when we're using PyTorch is that it actually takes up quite a lot of room, and it can be sort of quite a big project. So what I'm going to do is I'm going to move to my desktop here. I've just been deleting some stuff in the background there. So at its easiest level, we can UV init minus bare, and I'm just going to call this PyTorch like that. So that's created an empty PyTorch project, and if we look at the pyproject.toml, you see there's nothing in there. All I'm going to do now is I'm going to UV add both NumPy and Torch, just because Torch accelerates NumPy on the GPU, and you need sort of both of them, although you can install Torch without NumPy if you wish. Now, this can take some time the first time you've run it. I've run it a few times, therefore I've got all the packages cached in the correct location, ready for me to run them. And that really does sort of help a lot when you're doing projects over and over again, that it's the first time it's really slow, next time it's going to be fine and quite fast. And the reason for this is the fact that there's a lot going on here. We've got all of these CUDA libraries. These need to be generated first time against the installed version of CUDA. There's various executable things and things that are set up. But now we should be able to just UV run like that. We should be able to import Torch. Again, you can see I've done this already to make typing easier. Importing Torch is always a bit slow, but this has now imported Torch, and we can now just check to see if we've got accelerated PyTorch available with CUDA, and then we can also generate a device using CUDA and print device or something else like that. But now we've got the ability to basically send offload work to the GPU with PyTorch, do our processing, and bring it all back. Now, that's fine for simple command line programs and anything you want to do Torch. A lot of the time when we're teaching this, we're doing all of this using Jupyter. So what I've got here is a machine learning template. Again, I'm going to choose the Python 3.13. Eventually, this is still being developed. Eventually, it will default to one version of Python and use that. So in this case, what we've got is the ability to, I'm going to choose my desktop again, there, and I'm going to call this Jupyter Torch, like that. And basically what I can do is I can choose, so Matplotlib, NumPy, Qt console I'll demonstrate because that's useful. I'm not going to install pandas, I'm not going to install Polar, I'm going to install Torch. I'm not going to install Torch Vision at the moment, or TQDM, because I don't need them. And I'm going to do the auto activate stuff at the end. And what I'm going to do is I'm going to create this project. Again, this can take a little time to set up and get running, but once it's there, we should be able to change into it. It's just the nature of these machine learning projects. They are rather large sometimes. So this is called Torch, Jupyter Torch. There we go. So change into that folder there. And one of the things that will get generated with this once it's finished installing all the packages is some of the shell functions to make it easier for us to do the launching of Jupyter Notebook for the Qt console. So you'll see now at the end there's a few extra bits there, and it's generated the things there. So I should be able to run Jupyter Qt console. That's going to fire up the version of the REPL in a Qt console. Here it is here. And that allows us to do all sorts of interactive stuff. It's a bit better that we can inline num plots and things. It's basically the same as Jupyter, but in a terminal. So again, I can import Torch like that. And we can see that that's all going to work, and it should be ready to use. And I should also then be able to sort of go through and query if Torch is available once it's done its thing, and I should be able to paste that in so we can see that's available, and it's happy with that. Close that down, quit that. And obviously we've also got Jupyter Lab that we can run. He says, why did that not work? Jupyter Lab, there we go. We've got Jupyter Lab that we can run, and we can go through and do our standard Jupyter stuff. Now, when I create student projects, I basically have this PyProject TOML as part of it, and a series of workspaces, which I'll discuss in a little while, which just set this up as default. So basically when these things run, they are ready to go. All of PyTorch that we're going to use in the teaching is there. If we need any extra project elements, then we can install it with UV ready. The downside of this, as we'll see, I'll just wait for this to install and run, is if we look at the size of this, so du minus hs, we'll see the VM now is about 5 gig, which obviously is quite a lot, but again, this is why now I've got VM Cleaner, where I can run that, and it's going, I'll find the VMs for you, and we can delete them. So there we go, let's delete that, and we can delete it for us. Interesting that DU gives us 5.1 gig, and this gives us 4.98 gig, which is interesting. Oh, I suppose because I've got other elements in my folder which I'm getting from it. And again, we can go in here, we can do our import torch. We can then go through and query if torch is available. I'm just going to paste that in because I always spell available wrong. I should be able to run that. And now that should give me my results once it's loaded it all in. As you can see, that's all cleaned up, which is nice. And there we go, so it's found it true. So I'll be using this setup in all of my machine learning projects when I'm using like Jupyter Lab and command line tools and everything else, and it makes our life nice and simple and easy. Now the final thing I'm going to mention in this is the use of the UV workspaces. Basically this allows us to share one VM amongst multiple folders, and effectively all we need is a PyProject TOML in each subfolder that uses it. And what I'm going to just open up the entire project here so we can see. What will happen is that UV will try and share as much stuff as possible. So what we'll see here is there is a top level PyProject.toml here with the dependencies that I use and stuff like this. And then you can see there's this tool.uv.workspace, and each one of these folders, and notice the star here, it will recurse through, will have its own PyProject.toml. And what that means is I can change into the folders, and I should be able to just, I haven't got one there, run the programs. So for example, try term. First time run, obviously UV has just gone and synchronized and set everything up for me. And then it should just start running the program once it's installed all of the dependencies for me. And that didn't work for some reason. I'm not sure quite why that one didn't work. This is all new code ready for next year, so some of it isn't. So that one worked, and it should have generated output PNG and created a triangle, and hopefully Qt try will work as well. And there you go, so it generated a triangle there. But if we have a closer look there, you notice there is no VM there. And if I change into any of the other folders and run now, again it's doing the same thing. It's running all of the code, doing stuff and so on. But because this is all workspace, we are sharing the root project there. which again, it does make life a lot easier that you're not generating lots and lots of stuff each time. So again, this should hopefully just run. And again, it won't generate extra dependencies or anything else like that. And you can see it's just generating our code and so on. So it's a very useful setup. It takes a little bit of work just to get it going, but what you'll see again is when we run our VM cleaner, it'll go through and you can see it's just got one VM there, relatively small in this case. It's 4.89 meg, so I can delete that. That will delete the contents of that. When I try running it again, UV will recreate our project and our workspace, and I should be able to go to any of these. So again, if I just go, let's go to Cube because we haven't run that one yet. If I run that, UV run webgpu.py, and you can see again it's installing the Python version. It's recreating that virtual environment for me, and it's setting it all up. I haven't set this up to do auto UV sync and everything else yet. That's part of the development that I'm doing at the moment, and it should be running it all. For some reason it didn't. There it is. And there you go again. So workspaces are well worth getting used to and understanding because it will save you a lot of hassle in the long run. You basically say these are the folders that have a pyproject.toml, exclude everything else so it won't search for them and it won't complain, and you'll only ever have one VM. RTFM. The docs are excellent. Go through, start looking at them, look at all the different tools, understand how they work, and it'll give you lots more information. Same with Z, OMI, Zsha, and so on. So hopefully that's giving you an idea of how we're going to work. This is the way I'm working with all of my Python teaching this year. It should work across Mac, Windows and Linux with no real issue. I develop them on my Mac first and move it to Linux. I don't use Windows. I'm not going to use Windows, but most of this should work on Windows. A lot of the code is tested in CI, in GitHub Actions on a Windows machine. So I'm hoping that's enough to test. Any more questions or anything else, just ping me a message and I can go through it with everyone.